In this video, we'll be learning how to find volume of revolution. So I've got two questions, one where we're rotating around the x-axis and one where we're rotating around the y-axis. You're pretty much just using a formula to evaluate this volume. So the two formulas that we're going to use for volume of revolution are as follows. So the first one is pi, the integral, and then you're going to have limits. So I'll just write that as a to b of x squared with respect to y. So this one is when you're rotating around the y-axis, and if you're rotating around the x-axis, it's pi the integral from a to b of y squared with respect to x. This is for the x-axis. Alright, so let's look at some examples and actually apply these two formulas. So here we're given that the diagram shows part of a curve with the equation y is equal to x squared plus 1. The shaded region enclosed by the curve, the y-axis, and the line y equals 5 is rotated through 360 degrees about the y-axis. Find the volume obtained. So let me see if I can draw the actual rotation just so that you guys can visualize what's actually going on. So this is a rotation around our y-axis, so we're also going to have that part reflected on that side, and so it's going to look like this since it's rotating. Okay, and so this here is going to be the volume that's produced or obtained, and we need to find that volume. So to find that volume, we're going to use pi the integral of x squared from a to b with respect to y. So our limits here, this is with respect to y, so our limits are going to be from 1 to 5. So we know that is pi the integral from 1 to 5. Then here it says x squared. So our equation here is y is equal to x squared plus 1. What it means is that you have to make x squared the subject of the formula, and you get the expression y minus 1. So remember that this is with respect to y, so you want the equivalent of x squared but in terms of y. So that's going to be y minus 1 with respect to y. And now we can go ahead and integrate. So that's pi. If you integrate y, that becomes y squared over 2. If you integrate 1, that becomes y. Our limits are 1 to 5. So pi, let's start by substituting in the upper limit. That's 5 squared over 2 minus 5. And then the lower limit, that's 1 squared over 2 minus 1. So let's simplify. So we've got the upper limit being 5 squared over 2 minus 5, which gives us 15 over 2. And for the lower limit, that's 1 over 2 minus 1, so minus 1 over 2. And so this is going to be 16 over 2. So pi times 16 over 2, which is 8, so we end up with 8 pi. So the volume obtained is 8 pi units cubed, if you like. That's going to be the volume obtained when we rotate 360 degrees about the y-axis. Alright, now let's look at an example where we're rotating around the x-axis. So given that the diagram shows part of the curve with the equation y squared is equal to x minus 2, and the lines x equals 5 and y is equal to 1. The shaded region enclosed by the curve and the lines is rotated through 360 degrees about the x-axis. Find the volume obtained. Let me see if I can draw the volume generated so we can visualize our problem. Okay, so here we're gonna have this line continuing downwards, and then we've got a line at y is negative 1. Yeah, I think that's fine. So the rotation, so our shaded region is this part over here. And so when it rotates, the shape that you're going to get looks like this. And then on the other side here is going to look like this. But we only want the shaded bit. So we can create an expression for our volume to say that the volume is going to be volume under curve. So I'll just write it as volume under curve. If we were to get the volume of the whole curve, it's going to get the volume of this whole thing, right? But we don't want the volume of the whole thing. So we're going to have to subtract the volume that's generated by the line, which is this volume that we have, which I hope that you can see forms a cylinder. Alright, so we need to subtract the volume generated by line, or the cylinder generated by line, which is also just a cylinder. So let's start by getting the volume under the curve. So that's going to be pi, the integral. Our limits are, we need to find the x coordinate at this point over here. This is the point at which y is 1. So that becomes, using this equation, that becomes 1 squared is equal to x minus 2. So that means x is equal to 2 plus 1. So x is equal to 3. So x is 3 at this point. And then at this point, we're given that our x is 5. So we're integrating from 3 to 5. And since this is around the x-axis, it means that this is going to be y squared with respect to x. So we need to make y squared the subject of the formula. It's already subject of the formula, so we can just pick the expression x minus 2 and substitute. So that's pi, the integral from 3 to 5 of x minus 2 squared with respect to x. Alright, and so let's go ahead and integrate this. So that becomes, add 1 to our power, so x minus 2 to the power 3, divide by the new power. Alright, and then differentiate x minus 2, you get 1. And this is all from 3 to 5. Okay, so that becomes pi, that's x minus 2, the power 3, let's just get rid of that 1, from 3 to 5. And now let's substitute in our limits. We'll start with the upper limit, so that's going to be 5 minus 2 cubed over 3 minus our lower limit, that's 3 minus 2 cubed over 3. Alright, and so let's simplify. So pi 5 minus 2, that's 3 cubed, 27 over 3, that gives us 9, minus 3 minus 2 cubed over 3, so that's going to be 1 over 3. So that's 9 minus 1 over 3. So we get 26 over 3 pi. So this is the volume generated by the curve. But we have to also consider the volume generated by the cylinder. Just so I can clearly show the cylinder, let me get rid of these red lines. Our cylinder would look like this. Is from this circle that we have at the back, and then it goes up to this point. That's where we're going to have the other face of the cylinder right there. Okay, so we have to subtract the area of this cylinder, and we know the formula for volume of a cylinder, that's going to be pi r squared h. So we need to figure out what h is and what our radius is. So our radius is the distance from, our diagram is quite terrible, but the radius is going to be the distance from this point up to that point. So that distance is 1. So that's pi times 1 squared times our height. So the height is going to be the distance from this point to this point over here. So that's just 5 minus 3. So 5 minus 3. Okay, so if we simplify this, this is 2 pi. So it means that the volume of the shaded region, or generated by the shaded region, is 26 over 3 pi minus 2 pi. So the volume is going to be equal to, let's punch this into the calculator, 26 over 3 minus 2, that is 20 over 3 pi, units cubed if you will. Yeah, I guess an instructive moment here. Turns out I made a mistake. I hadn't noticed it in the process. Some of you might have noticed that mistake, but the mistake is when I was substituting x minus 2. So our equation is y squared is equal to x minus 2. Y squared is equal to x minus 2. So it means that I should just have replaced y squared with x minus 2. There was no need to square there. And so that means our volume under the curve is incorrect. So let's correct that, so we can get the correct final solution. So that's pi, the integral from 3 to 5 of x minus 2 with respect to x. So that becomes pi. Integrate x, you get x squared over 2, minus integrate 2, you get 2x, and this is from 3 to 5. Alright, so pi, let's start by substituting in our upper limit. That's going to be 5 squared over 2 minus 2 times 5. And now let's substitute in our lower limit, so that's 3 squared over 2 minus 2 times 3. And so that's pi. Let's simplify our upper limit. That's 5 squared over 2 minus 2 times 5. That gives us 5 over 2. And for our lower limit, that's 3 squared over 2 minus 2 times 3. That gives us a negative 3 over 2. And so this ends up being 5 plus 3, which is 8 divided by 2. So we end up with 4 pi. So it means that the volume generated by our curve is actually 4 pi. And we say the volume generated by the line, so by the cylinder, is 2 pi. So our result is going to be 4 pi minus 2 pi. And our final answer should be 2 pi. And so that's it for the volume of revolution video. Make sure to go through the quiz.